Yep, back again. This time looking at a Codewars exercise called Adjacent Double Letters. I think this is a newer one, and it's a good one. I did this one for the first time a couple of days ago, and I liked it, so I'm putting it on here and giving it some pub. So this one says, given a string which is a word, return true if the word has adjacent double letters, like balloon. And the adjacent double letters are the LLOO. So it's like a string of 4 letters where you've got 2 that match and then another 2 that match. And we'll continue on. For example, yes, a balloon has the LLOO, adjacent double. L's double, O's double. You go down here to this other one. This other form of balloon is false because you got one set of doubles not adjacent to the other set of doubles. So they are separated. Yes. And moving down a little bit more, we see baboon is true because the 2 O's, the 2 N's. Mat is false because only one set of doubles. You need double, consecutive. Yeah. And going down here, this one is okay because it doesn't say that the doubles can't be the same, and here they are the same. You got 2 A's and then 2 A's and then 2 more A's, but we only need a string of 4. But this is acceptable because there are adjacent doubles. They just happen to be the same across all 4 characters, but it's all good. So that works as well. So it's good to know that the doubles don't have to be different doubles. They can all be the same character, so that's good. And you can use that as your part of your kind of logic if you want to. I didn't really have to do that, but depending on how you want to craft it, it's up to you. So yeah, overall we got to find, and yeah, this one returns true or false, and it'll return true if we really got to find a set of doubles. So if you find 2 characters that are the same, find 2 more adjacent that are the same. So really for any set of 2 characters that are the same, you need to look at the next 2 to see if those are also matching each other. And that's really the task here. Find 2 that are the same, and every time you find 2 that are the same, look ahead 2 more and see if those 2 are the same as well. So maybe the wheels are turning in your head a little bit because some of you more experienced people, this is a fairly simple one. And so I'm going to start my loop in here. And I forgot to mention that this is a Python exercise, but you can see Python prominently centered near the middle of the screen with my large type here. But yeah, this is Python. And I'm going to do a loop. I'm going to loop through the string, and I'm going to loop the length of the string, and my endpoint is going to be -3 actually, not looping all the way to the end. It is because I'm going to always be looking ahead in my matching scenario. I want to be able to look ahead 4 spaces basically. And if I loop all the way to the end, I'm not going to be able to do that. I'm not going to be able to address like I plus 1, I plus 2, I plus 3, I plus 4. Well, don't need I plus 4, but I plus 3 would be the last one that I would potentially address. But I can't do that if I'm going all the way up to the end. So I create a limit that's going to allow me to look ahead. And actually, as I think about this, what I'm actually employing may not even require this limit, but it's still good to set. I've kind of got maybe a hybrid solution. So I'm using slicing, and slicing doesn't really require a limit because you can actually go out of bounds, so to speak, with a slice, and it's okay. And I'm not going to get into that, but those who know. So actually what I'm going to do here, I'm going to create a slice looking at really from where I am right now, my current element, and I'm just going to go 4 ahead. So I'm just going to look at like every 4 characters, do I have a double-double? That's really what I'm going to do. It's very kind of linear and straightforward. So I'm just going to check for double-doubles at each element, up until I get to into my limit. So here's how that's going to look. I'm going to create a slice, and I'm going to call it slice, and it'll be word, and it's going to go from I, which is the current element, to I plus 4. And what that's going to do, it's going to give me I plus 1, I plus 2, and I plus 3. Of course, the end is not inclusive, so it's not going to include I plus 4, but I to I plus 3, that is 4 elements. And I'm going to look at those 4 elements to see if they are double-doubles. So create my slice, and then I can do an if statement. It says if the first element of the slice is equal to the second element, and the third element of the slice is that's equal to the 4th element. This is really the double-double logic, where it's kind of like this. If this was I right here, let me get the pen out here. If this was I, it's going to say, okay, is I plus 1 equal, which is the second L? Yeah, it is. And if those are equal, how about I plus 2? Or I guess you could say index 2. Is this equal to this? Absolutely it is. So you got to check there, and then that's going to return true. That's really what I'm doing here, is element 0 equal to element 1, and is element 2 equal to element 3. If that and is satisfied, meaning both sides are true, then I've got my double-double. So if I got the double-double, I'm returning true. Good stuff. And otherwise, I'm returning false if I get to the end of my loop and I have not returned true. I'm going to return false. This one is just that simple. And I'm going to pass this one through to see what's up. Is it good? Is it not? It's good there. Impressive. Good there. Out freaking standing. Thought I was going to say something else, didn't you? Nope. Not today. Yeah, set my limit. Get a slice of really the next 4 characters, and then check them for double-doubles on line 4. If you got a double-double, return true. And if you get to the end of the loop without returning true, you return false because you haven't found double-doubles. And it's all good. And whenever the exercise passes muster, so to speak, that's my ticket to be out of here. So I'm good. The code is good. It runs. You got some quality explanation today. You can go into your day satisfied and hopeful. So that's it for me, and I'll see y'all later.